All right, so 6.2, we are going to start with a warm-up on slope first, but we are heading into another algebra concept, which is distance formula and how it applies to the geometry. So this is just a quick review of the slope that you saw yesterday. It says 2 out of 3 boxes don't belong. One of them, or I'm sorry, 2 out of the 3 boxes do belong together. One of them does not belong. Circle the representation below that does not belong with the other 2, and you're justifying how you know that. So first start off with just finding the slope of all 3 so that you can then decide which one doesn't belong. The first one you're going to use like rise over run. You can draw in that triangle. So you're going down 6 spots here, so -6, and right 3. So when I find the slope for this, remember it's rise over run, so we have to do the vertical first and then the horizontal, and that comes out to a -2 for the slope of that first one. Now let's see, are the other ones also -2, or what do we need to do? What do we get for each of those? And so the second one, we do have to use a slope formula. So -10 minus 8. I did my x2 minus x1. I'm sorry, my y2 minus y1, and then x2 minus x1. And don't forget to be careful with your negatives. So this would end up being -18 over a +9, because those 2 negatives will make a positive, and we get -2 also. So far it looks like these 2 do belong, so probably that last one isn't, but let's make sure when we find the slope using the formula again. This time it's 4 minus 2 and then 2 minus 2, and it does not work. This is actually an undefined slope, but it also is not -2. That's the one that doesn't belong. And for your reason, you can just kind of justify and explain it a little further, something along the lines of like, this last one doesn't belong because the slope of it is undefined, whereas these 2 have a slope of -2. Something along those lines. All right, so that was just a quick recap of what we did yesterday, because you don't want to forget about slope. Sometimes on the homework there's some examples where, some questions where it might ask you to do slope and the new stuff with distance formula that we're about to see. Okay, so let's go to the next page where we are going to start with kind of a in context problem, trying to understand distance formula a little bit better. But just like it sounds like, you're going to find the distance of things today. And so here is the scenario. It does say here, suppose that the city in which you live has a system of evenly spaced perpendicular streets, forming square city blocks. The map below shows your school, your house, which is located 2 blocks west and 5 blocks north of the school, and your best friend's house, which is located 8 blocks east and 1 block south of the school. So they're using a lot of the cardinal directions, right? North, east, south, west. You might hopefully remember that already from like a social studies class. So if you want to label this compass to help understand it a little bit more, north is at the top, then it goes east, south on the bottom, and then west on the left here. That might help you to understand how they are kind of naming the relationship between each of these houses. So when it says your house is 2 blocks west and 5 blocks north of the school, when you start from the school, you're going to count 5 blocks north, that's going up 5, and then 2 blocks left to go west to get to your house. Same thing for how they explain how to get your friend's house. You can also do that. So what's happening here is that school is kind of like your origin. So if we kind of were to make your y-axis, this is our y-axis here, and then you make your x-axis this way so that you're creating school to be the origin. Now you can even name things about, where your house and your friend's house are. And so they did say your friend's house is 8 blocks east and 1 block south of the school. That's exactly what we're seeing here. Right 8, down 1. Okay, so now it says, let's kind of do some understanding here, analysis. It says, how many blocks would you have to drive to get from your house to your friend's house? You want to draw the path that you would drive and calculate that distance. So if you're driving, you cannot go like diagonally, right? We can't cross through all these streets. We have to go actually making horizontal and vertical lines to get there. So from your house, which I'll do this in a different color here, from your house to your friend's house, you're going to first start from your house, and you're going to possibly go to the right here. We're going east a certain amount, and we're going to go up until we're right on top of our friend's house, and we'll stop there. Okay, so right here at this point. Then you're going to go down or south a certain amount until you hit your friend's house. The amount here, if you were to count the boxes, there are 10 boxes going this way to the right, because then that's 10 units east, or 10 blocks east, and then down we go a total of 6 units, so it's 6 blocks south. So when you say how do you go from your friend's house, or from your house to your friend's, you're going 10 blocks east and 6 blocks south. And so you could count how many blocks that is. It's 10 plus 6. So if I was to calculate the total distance that I would be driving, I would have to do 10 plus 6, which is 16 blocks. You don't have to show work for this, but we're just kind of seeing where does that come from. It says, though, what if you had a helicopter? You could use a helicopter and fly straight from your house to your friend's house. Then we wouldn't need to drive like these horizontal and vertical lines. We wouldn't have to go straight. We could go the straight distance, that diagonal from your house to your friend's house up in the sky without having to worry about the roads. And so if I was to connect just straight from your friend's house and your house like this, and we could then figure out a way to calculate this, that would be the quickest way to get there. So here's our dilemma. How do we calculate this? Well, we've done this before back in Unit 1. This is a right triangle that we just created here. And when we have right triangles, we can use Pythagorean theorem, because the triangle we're working with here is 10 for one leg, 6 for the other leg, and we're trying to find this distance, which I could call x, I could call it whatever letter I want. So if I'm going to call this x, and I want to use Pythagorean theorem here, this would be x squared equals, that's hypotenuse squared, 10 squared plus 6 squared. And then we would start calculating it. 100 plus 36, or use your calculator to get 136. And then I don't want x squared, I want x, so I square root both sides, and I'm looking at the square root of 136. Problem is, we don't usually leave our answer like that. It does say, though, that you can round to the nearest hundredths of a block, so we are going to write this as a decimal, but just so that you have practice, I would say consider trying to simplify that radical. See if you know how to simplify, because that's not going away. That's a skill you need to do in geometry and in Algebra 2 and Trig next year. So when you do 136 divided by 4, for example, because it's a perfect square, we do get 34. 34 doesn't have any perfect squares in it. So you could break this down into square root of 4 and square root of 34, which comes out to 2 root 34. So this is simplified radical form. I know it didn't ask for that, but when it says find the distance as the crow flies, that just means like while we were in our helicopter, or if you imagine a bird or a crow specifically being able to fly across like this without having to go a certain amount to the right and then a certain amount down, this is the fastest distance there. This is what I want the calculator to tell me what it is as a decimal. So you can type in either square root of 136 or 2 root 34, because they are equivalent, and you'll get the same decimal answer, which is approximately 11.66, because we need to round to the nearest hundredths, it says right here in the directions. So about 11.66, and then don't forget the units. We are working with blocks. Well, that's good news then, because this answer is obviously less than the 16 blocks that we would have had to go if we were driving there. So obviously much quicker to be able to get there straight using a helicopter, or if you were a bird or whatever. And so now it says, can you establish a coordinate axis system? We actually did this already at the beginning, where we drew out the x and the y axis using school as the origin. Okay, so if school is the origin, we need to think about what would our coordinates be for your house and your friend's house. So kind of just think about counting from school. You're going up a certain amount, left a certain amount. And remember, when you write coordinates, we always write the coordinate going left or right first, the x value. So this is -2. And then when you go up 5, or sorry, it's up Yep, 5. 1, 2, 3, 4, 5. That would be our coordinate. -2, 5. Do the same thing for your friend's house. You're going right 8 and down 1. So 8 goes first because it's the direction for horizontal, or x, and then -1 gets you down for the y value. So we have our two coordinates here, and I'm going to even write them here so that in case you can't see it from the graph, we can see it in our work here. So our house was at -2, 5, your friend's house is at 8, -1. And now we're about to use these coordinates on number 4, where it says, how could you use the coordinates you identified in number 3 to calculate the distance as the crow flies? From your house to your friend's house, rather than counting the lengths of the legs like we had to, where we said, okay, 10 units and then 6 units, it says, could you do something else instead of just having to count the legs of the right triangle? And so here's how we can demonstrate this. I'm going to write it in words first, and then hopefully we can show that with the coordinates. And maybe you could think of this yourself, but let's just write down what we can do here. We can subtract the coordinates to find the distance of the legs. So if you don't want to just count the distance like we did when we first said, okay, we're going 10 blocks and then 6 blocks, instead you can subtract your x coordinates and your y coordinates to find the actual distance of the legs that you first start with. Then by squaring both of those legs, we're kind of doing the Pythagorean theorem, or I'll just say square, not squaring. Square both numbers. That's the distances that you found. You're going to square them both. And then finally, square root your answer, because we're trying to take the square root of it when we do Pythagorean theorem. Kind of like following these steps here, but it's saying here that if you don't want to count to get 10 and 6, what's another way to do it? Well, you would just subtract your x and y coordinates. So here's what this looks like then to find this x, let's say, because I labeled this diagonal x already. So I would subtract my x values and my y values, right? So my x values are 8 and -2. So I could do 8 minus a -2. And then in addition to that, I'm going to add these together because I want to deal with my x's and my y's. Like, how do you go horizontally and vertically? So then the y values are 5 and -1. It really doesn't matter which one you pick first or second, but I'll just go ahead and pick it in the same order that I picked, just like how we do slope, how we did slope on Tuesday. So same idea. So this is -1 minus 5. And now here's where we did the first step. We subtracted it. Then it says, can you square both those numbers? So squared here, a squared there. And finally, can you square root? We're going to square root this entire thing. Okay, now if we were to try to calculate this, you could use a calculator to help you, but I wouldn't just necessarily type the whole thing in, just because, well, you could, but let's see what it comes out to if I don't. If I just want to write like the number. So this would be like 8 plus 2, which is 10. And when I square that, I get 100. -1 minus 5 is -6. Now when I square a -6, I have to put parentheses around it, because if you don't, you're going to get the wrong answer for that. We have to do square root of 100 plus 36. And again, you can use your calculator to help you with any of these calculations. I can do this without, and I just get to square root of 136, like we said earlier. It was the same answer if we just used Pythagorean theorem, but this is getting us ready for distance formula. So you might say, well, can't I just do Pythagorean theorem every single time? Why do I have to do the distance formula? Well, sometimes you're not going to always have a diagram shown. What if I just have coordinates? I don't want to draw a diagram just so that I can see if I can do Pythagorean theorem. But this answer would still be the same, which would be 11.66 blocks. We just found it another way. Okay, so we're about to summarize now at the bottom here where it says, what is this distance formula? Because you want to be able to use it for any two coordinates that you have and whenever you're trying to find the distance between them. So here's the first one. It says, using your answers from the exploration above, write a formula for the distance between any 2 points. Now notice how these points are written similar to how they were for slope when we worked on finding slope. One of the coordinates just has a 1 with it, and the other one has a 2. The good news here is with distance formula, the order here does not matter as much, whereas slope, of course, you know that when you do y2 minus y1, you have to do x2 minus x1, otherwise your answer will be incorrect when you have that fraction for slope. But here, for distance formula, I'm just using the letter D for distance, but you can use any variable. It's one big square root, and inside of that, we're going to have our two x's. Now, it doesn't technically matter what comes first, but I'm just going to go in order. So we're going to say, let's take the x's, x2 minus x1, and subtract them, like we did up here when we were working with those coordinates. And you're squaring that whole parentheses. Do the same thing for y2 and y1. Again, the order won't matter, but you do have to square it. Now, here's where common mistakes happen. When you square something that's in parentheses, like these are, you will always get a positive answer, no matter what. If you are getting a negative answer for one of these, something's going wrong. So you want to either use your calculator with parentheses around it like this to square each of these and then just add them together. And then you will probably have to simplify some radicals today, even on the homework, and we'll see a little bit on the next page as well. Okay, so as we get to the next page, this is just your practice. Remember, usually we pick like one or two to do together, and then you can try the rest out for some more practice, or do your homework first and then maybe come back to it at a later time. But remember, the practice is there so that you can hopefully get just the gist of something, just to get more of an understanding on some of these. So let's go ahead and see which one we will pick, one or two of them at most, and then we'll be all set here. Okay, so the two that we're going to kind of look at today is going to be number 2 and then number 5, because those ones I would say are similar to things that would be on a quiz or a test as well. The first one is just a basic, can you use the formula? And here it is one more time at the top here, in case you don't want to flip to the front page. It is subtract your x's, x2 minus x1, and square it, and then subtract your y's and square it. All inside one big square root. And so when you get to number 1, if you want to try this one out, you just want to start by taking your coordinates. You can call them x1, y1, and x2, y2. It does not matter which one you pick for 1 versus 2, but you could assign them different, like you could write it right on here, and then it would make it easier as you go to do x2 and y2 and so on. So like if I want this to be x1, y1, I could have this be x2, y2, for example. And then you could just substitute and keep solving or simplifying until you get to a point where it wants to know the exact length and the approximate. Exact means simplified radical form. That means you're not done until you can't simplify the radical any further. This one will have some simplifying to it that's needed. So if you decide to try this one out, you are going to end up with the square root of 45, which simplifies to 3 root 5, but then so this is our exact answer. The approximated answer you will need a calculator for. You're going to type it into a calculator as either square root of 45 or 3 root 5, and you get approximately 6.71. And so we could leave our final answer like this. NM equals, or is approximately 6.71, and it's better to put a U for units, but you don't have to do that part. And then writing it as an exact answer, we know would be 3 root 5. Again, you could put the U for units. Okay, so that's just answer number 1. I know you can check Canvas anyways, but just wanted you to get an idea about exact versus approximated. Let's try number 2 though. The reason I like number 2 is because not only are you using the distance formula, but you're doing more with it. And that's exactly what you'll need to do for number 5 as well. And some of this should hopefully be on the homework. It says a lake is shown below and an island is located at 4, 5. A boat travels in a straight line from 2, 0 to the island. And if the boat travels at a speed of 20 miles per hour, how many minutes will it take to reach the island? And it does tell us that 1 unit is 1 mile. So the first thing you do is just start with the distance formula with the 2 points that we have, which are at 4, 5, and 2, 0. And it does not matter which one you put first or second, but just make sure you're always subtracting your x's and subtracting your y's. Don't mix the two up. So I did 4 minus 2, and then I would do 5 minus 0. But again, yours could look different from mine. When you first set it up, you could have done 2 minus 4, and then 0 minus 5. But no matter what, when you square those, we should both end up with the same answer. So then this would end up being 4 minus 2 is 2. When you square 2, you get 4. And 5 minus 0 is just 5. When you square 5, you get 25. And that simplifies to the square root of 29. Now this can't be simplified any further, and I don't want to grab a calculator and round it because then my answer will not be as exact. So keep it where it is right now, but this is the distance it takes to travel between the island and this boat, and we need to figure out how long it's going to take the boat to get there if it's traveling at a speed of 20 miles per hour. And so this is where there is an equation that we use for distance and time. And this is something you might have seen in physics. I know many of you are in it or have taken it. So distance equals rate times time is what this equation is. And anytime you're working with time and a speed, this is what we use with distance. So our distance we know is square root of 29. Our rate we also know is 20 miles per hour. What we don't know is the time, so I call that t. If I'm trying to solve for t, I would divide by 20. And here's where you would grab a calculator, and it's okay to round now because our final answer will be rounded as well. Square root of 29, and we want to divide that by 20. So when I type that in, I get about 0.269 roughly. And I'm just rounding it to 3 numbers, but you could do more. I wouldn't do less though. Okay, so 0.269 now. The answer I just got though is in hours. I want to know how many minutes because that's what it says in the question. So now we need to take this answer and multiply it by 60 because there are 60 minutes in an hour. Right, so times 60, and we can use our calculator to do that. And this comes out to about 16.2, or you can round to, again, 3. It doesn't say how much to round to, so you can round how you want to. So 0.269 times 60 comes out to 16.155. And our units here, remember, are in minutes. So it's saying here that it's a little over 16 minutes that it takes the boat to travel from here to here because of the distance that we knew of. All right, so that's it for number 2. We're going to finish up with number 5, and the hardest part of number 5, or like the part that kind of gets to be a bit tedious, is you're having to find the area. In order to find the area in the perimeter, you're having to find all 4 sides of a shape. And in our case, this is a rectangle. So as I have my rectangle here, it says, can you find the exact area and perimeter? The word exact tells me I don't want to round. I'm going to need to leave things in simplified radical form. Good news is rectangles have the same 2 sides, so we don't have to find all 4 sides. We just need to find 2 sides. And so it helps if you label your coordinates so that you can use the distance formula. This is 5, 2. This is 12, negative 5. And then we have 9, negative 8 here. And finally, this is 2, negative 1. So now that we have our coordinates, we can find the missing side lengths. Okay, so here's, if you want to call it like letters, like this is A, B, C, D. I'm just using lowercase letters there. You could use a different way to name it. You could name your point something, just so you have a way to name this. We know A and C have to be the same, and we know B and D have to be the same. So let's see what we get for each one. For A and C, we want to do 2 minus, I'm sorry, that's the x value. So 2 minus the 5 squared. And do the same thing for the y's. We have negative 1 minus 2 squared. Again, yours can look different from mine. Maybe you use the points for C right down here. Maybe you use the order differently, but we should get the same answer, which, let's see what we get. Negative 3 squared. When you square a negative number, and if you're not sure, try it out. Negative 3 squared, like this, comes out to negative 9. Or, I'm sorry, positive 9. It will always be positive no matter what when you square a negative. So we get 9 plus negative 3 squared again is also 9. 9 plus 9 is 18, but I can't leave my answer like that. I want to write it in simplified radical form because I need an exact answer. So this would be written as 3 root 2 because we know that 18 has a 9 and a 2 in it. Square root of 9 is 3, and the 2 kind of hangs out inside. So we found these two sides so far, 3 root 2, 3 root 2. And now we just need the second two sides. So we have to do distance formula one more time. So we have 12 minus 5 squared and negative 5 minus 2 squared. And here's what we have. So this would be 7 squared, which is 49. And then you get a negative 7 squared, which is also 49. That comes out to 98, which also can be simplified further. If you're not sure how, you can grab a calculator. It comes out to 49 and 2. So this would end up being 7 root 2. Okay, now that we have both of our, or actually all four of our sides, right? 7 root 2 here, 7 root 2 here. We just have to find the area and the perimeter. Remember, area formula of a rectangle is base times height. Base and height are just any of the two sides that form, these are right angles. Remember, it's a rectangle. So you can pick whichever two sides you want, but it's always going to be 7 root 2 and a 3 root 2 for the base and the height. It does not matter which one you call which. Now here's where students have some trouble because it's been a while since you tried to maybe multiply radicals like this. You have to multiply the number parts together. 3 times 7 is 21. And the square root parts together. So square root of 2 times square root of 2 is square root of 4. And we know the square root of 4 is really just 2. You don't have to show all this work. You can just write your answer, which comes out to 42. And we always put units for area, which would be u squared, because it didn't tell me the units. So we just found the area. To write the perimeter, we would have to add up all four sides, 2 of them being the same for each of the two sides. So you would do like 2 times 3 root 2 and 2 times 7 root 2. And when you try to multiply here, or even if you wrote it out for like all four sides out, you would just multiply the number parts together. So it would be 6 root 2 plus 14 root 2. But since these are all root 2's, you actually have to combine them. That's how radicals are added. Whenever you have square root of the same number, you can add them together by just adding the number parts together. 6 plus 14 is 20, and you get 20 root 2. Don't change the radical part. It stays root 2, and you put a u for units. That is my perimeter. All right, so we are all set here with area and perimeter. I know that was a little bit of a longer day of notes, but the next day should be a little bit shorter.